Today's lesson is on Pythagorean theorem, and although most of you have used this extensively in the past, we need to add a little bit more information into the Pythagorean theorem. So probably what you've learned in the past is that Pythagorean theorem, there's a missing word here, only works if your triangles are right triangles. The longest side, which in this case is called the hypotenuse, is always found across from the right angle. So if our right angle is here, this side would be considered our hypotenuse. The other two sides are both called the legs, and Pythagorean theorem says if you take one of the legs and square it, and another leg and square it, that it's equal to that hypotenuse squared. And we use this normally to find missing sides of a triangle. That's how you've learned it from middle school. However, we can also use it to determine whether or not the sides that are given are the sides of a right triangle. So as I look at the pieces of information that they give me in question 1, they give me the length of all three sides. So these sides will be the sides of a right triangle, provided that if I put them into Pythagorean theorem, they will make Pythagorean theorem true. The hard part is that the longest side has to go in for the hypotenuse. When the side lengths are given in radical form, we can't always tell which one is the longest side in that form. So if I take radical 7 and put it into my calculator, it's about 2.6. And if I put 2 radical 6 in my calculator, it's about 4.9. And if I put radical 31 into my calculator, it's about 5.6. So this side is the longest side, and it has to go in for C. So when I go through and I do this question, I'm going to test to see if those side lengths work in Pythagorean theorem. So it doesn't matter what I put in for A and B. So for A, I'll put in the square root of 7 squared, plus for B, I'll put in 2 radical 6 squared, and then for C, I'll put in radical 31 squared. And I want to make sure that the left side equals the right. So the square root of 7 squared is 7. 2 radical 6 squared is 4, 2 squared times radical 6 squared, 6. Square root of 31 squared, 31. So if I add the 7 plus the 24, it does equal that 31. And if I get 31 equals 31, I know that my Pythagorean theorem has worked. Therefore, when they say, is this a right triangle, my answer is yes, because the sides make a squared plus b squared equals c squared true. For question 2, they're talking about a square. They're saying that the perimeter is equal to 16. Remember that all of the sides of the square are equal, so if one of them is x, they all are, which means I have 4 x's that add up to 16, which means each side is 4. They want to know the length of the diagonal. So if I redraw my square with side lengths of 4, we know that a square has a right angle. And if we focus on this right triangle, we can do Pythagorean theorem and substitute in those side lengths of 4. So I have 16 plus 16, which is 32. I square root both sides, and I get plus or minus the square root of 32. And then remember, we only want the positive one in this case because it's a diagonal, a side length of that triangle. And I want the positive, and then I have to break up 32. And I'm going to split that into 16 and 2, which gives me a diagonal length of 4 radical 2. In question number 3, they're talking about a rhombus. And again, this forces us to go back to some of the things from previous units. And one of the things that we learned is that if we have a rhombus, we know that in a rhombus, the diagonals are perpendicular. So that means that each of the triangles in there are right triangles. It says the side of a rhombus is 10, so all of them are technically 10. and the shorter diagonal is 12. That means that this diagonal is 12. Diagonals bisect each other, so each half is 6. And if I put my focus on this triangle, and I find the length of this side of that triangle using Pythagorean theorem, I can double it to get the length of the whole entire diagonal, because that will be x over here as well. So the whole diagonal will be 2x. So when I do Pythagorean theorem, I have a squared plus b squared equals c squared. That's x squared plus 6 squared equals 10 squared. X squared plus 36 equals 100. X squared is 64. I square root both sides and I get plus or minus the square root of 64. Obviously, we only want the positive one, so our x value is 8. Remember, the longer diagonal isn't just 8, it's 2 times that x value, so it's 2 times 8, which will give me 16. So the longer diagonal in this case turns out to be 16. On question 4, it has a little bit more algebra in it. And again, we've talked about numerous times in this unit how a lot of the issues will become algebra issues. They're not really geometry issues. So please do not be surprised if that ends up happening, where you're looking at a problem and what you're having trouble with is the algebra, not the geometry. So this question says that we have a rectangle, and the length of the rectangle is 7 more than the width. So I don't know the width, but the length is 7 more than that. And the diagonal is 8 more than the width. So x plus 8. Remember, the rectangle does have a right angle. So if I focus on this triangle, it's a right triangle, and I have representations for all 3 side lengths. So I'm going to use a squared plus b squared equals c squared. So x squared plus x plus 7 squared equals x plus 8 squared. And when we get to this point, please remember that right here and right here, you need to FOIL. If by chance you need to go on the side and write down x plus 7 times x plus 7 and do your loops and FOIL that out, by all means feel free. And then you could do the same thing with the x plus 8 if you want. So you would have x squared plus 16x plus 64. So this x squared stays. And then we're adding on what we get when we FOIL this. So that's another x squared plus 14x plus 49 equals what we get when we have x plus 8 squared, x squared plus 16x plus 64. And there's probably a lot of you that can kind of do that in your head. In this particular case, if I minus the x squared from both sides, they're going to cancel. I'm going to minus the 16x from both sides. And I'm also going to minus the 64 from both sides. I recognize that this was a quadratic equation because of the x squared, and I'm sure some of you also noticed that. This x squared here indicates that you're going to have a quadratic equation. You want everything to cancel so you get it equal to 0. So I have x squared. Combine these two and get minus 2x. Combine these two and get minus 15. And then from that point on, I can continue solving. It looks much more simplified once you get it equal to 0. We know at this point, we can go through and factor. So x minus 5 and x plus 3. Make our t-chart. X minus 5 equals 0. X plus 3 equals 0. So I end up with x equals 5 and x equals negative 3. Clearly, this side would be rejected in this case. We don't always reject a negative number, but in this case, because we can't have a negative side length, they do ask us for the dimensions of the rectangle. So the width of our rectangle is one of the dimensions, and that's 5. The length is x plus 7, which is 5 plus 7, which gives us a length of 12. So when they ask for dimensions, dimensions are length times width. You do not need to write the length of the diagonal. That is not one of the dimensions of the rectangle. On the next page, question 5 is a Common Core question to prove the Pythagorean theorem. We're going to skip that for right now. I'm going to go ahead and talk about the couple of questions that are at the bottom of the paper. And at the bottom, it's telling you that you can to classify the kind of triangle you have. You can classify it as right if a squared plus b squared equals c squared. You can classify it as an acute triangle if when you do a squared plus b squared, it's greater than c squared. So what ends up happening is the c squared gets a little smaller, and as this side gets a little smaller, this angle gets a little smaller, and it becomes less than the 90 degrees we had here. If a squared plus b squared is less than c squared, it becomes an obtuse triangle. What that means is that this c has gotten much longer, and as it's gotten longer, this angle's gotten bigger, and if it's bigger than 90, then it has to be obtuse. So in the questions that you see, they ask you to determine, first of all, whether you can actually have a triangle, and then classify it as either obtuse, right, or acute. So we have to think back to something we did earlier this year, which was determine whether or not we actually even had a triangle. And our test to determine whether or not we actually even had a triangle was to say the small side plus the plus the medium side, when we add them, has to be greater than the large side. So when I look at that, my first part A to test whether or not it's even a triangle is to take the small side plus the medium side and test to see if it's really bigger than the large side. So clearly here we have 21 is greater than 15, so our answer to this question is yes, we have a triangle. Then they say classify the kind of triangle. So what I have to do is start out like I'm doing Pythagorean theorem, except that we don't know what goes in this box. It could be greater than, less than, or equal to. So we've got to do a little math before we fill in what's going to go in that box. So this is 49 plus 196, and then 225. So if I add this over here, I get 245, and I'm comparing it to 225. If that's the case, then my inequality goes this way. If I go back and compare that to the information up above, I'm comparing what happens when my two sides squared and added together turn out to be bigger than the hypotenuse. That means the hypotenuse has gotten smaller, which means the angle's gotten smaller, so it's less than 90 degrees, so therefore it's acute. So if I go back to this, and I know that this means that the hypotenuse is shorter, that means that my triangle is an acute triangle. It's less than 90. And we could certainly do the same thing over here in this next question. The only thing that could be a small little bit of a problem is the fact that we don't have decimal values. So in this case, if I go into my calculator and type in 2 radical 3, this is 3.46. 4 radical 2, 5.66. And then 3 radical 5, 6.71. Those are decimal approximations. It doesn't mean that they're definitely that size. That's a rounded value, but it's enough for us to be able to work with. So for my part A, I have to test and see if this can even be a triangle. I'm going to use the decimal approximations. So the small side plus the medium side has to be greater than the large side. So if I go through and do this, I get 9.12 is greater than 6.71. Therefore, yes, those can be the size of a triangle. Part B says to classify what kind of triangle you have. Again, it's the small side, and I'm actually going to use the radicals here. A squared plus b squared, the small and the medium sides, and I'm trying to determine how they compare to my c squared. So I'm going to square these. When I go through, 2 squared is 4, radical 3 squared is 3. 4 squared is 16, radical 2 squared is 2. 3 squared is 9, radical 5 squared is 5. So this gives me 12 plus 32. And I'm comparing that to 45. So I have 44 that I'm comparing to 45. that means my inequality goes this way. So if the sides are shorter in comparison and the hypotenuse must be getting longer the hypotenuse gets, the bigger the angle gets, so the angle will be greater than 90 degrees. And if the angle is greater than 90 degrees, then this must be an obtuse triangle. If by chance you are doing a question like this and you cannot have a triangle, in other words, your answer to part A is no, you cannot do part B. It would be like asking me what kind of dog I have when I don't have a dog. If I don't have a dog, you can't ask me what kind. So in this case, if I don't have a triangle, you can't classify what kind it is. So keep that in mind. If the answer to part A is no, you don't have to do part B.